hope you are well, and welcome to your video lesson for today. This particular video is not going to be that long, and the lesson packet questions that you have are also not that long, so the amount of time you have to do them today should not be a big deal. Anyway, the start of this lesson, being the first lesson in Unit 3, directly ties into what you were doing yesterday, but without the visuals that went with it. So in this particular question here, all you really need to do is just write in what do you notice and what do you wonder about these two graphs. Something that you might want to pick up on is the differences between the two. You may also ask some questions about what's on each graph and what the purpose of each graph is. Lots of questions for you. I think that a good target is 2 notices, 2 wonders for you to fill in on this question. For the next block, which basically is this same graph, or these two figures are both used for these questions, and we'll talk about what's going on in each one. And basically here's the setup. We have a sort of a starting line. Let's leave it like a race, right? So we have an ant here, we have a ladybug here, and at the start of the race, obviously both of them are at the starting line. And then 2 seconds later, the ladybug is here and the ant is here, and then 4 seconds later they're there, and then 6 seconds later they're there. Okay? So the questions that you're going to be asked about this, and obviously here is also a graph of showing these two. One of these two lines represents the ladybug, and one of these two lines represents the ant. Which one would show the ladybug's movement? Which one would show the ant's movement? So your job here is to figure out, and this of course, take a look at the way the graph is structured. Time is on the y-axis and distance is on the x-axis to kind of get an idea of what's going on there. I will tell you for future reference, generally whenever there's time involved, time is typically on the x-axis, but in this particular graph the time is on the y-axis. But I digress. What line shows ladybugs, which line shows the ants, and it shows the ants movement, and explain why. The second question is asking how long does it take the ladybug to travel 12 centimeters? Well, you're going to want to look at these particular lines here to kind of infer how long it's going to take for it to travel 12 centimeters. By the way, each of these lines does represent 1 centimeter, okay? So I want to make sure that that part is clear per line, okay? So that goes for all of these graphs, okay? So that means that here's the starting line. That's sort of our 0 reference point. The ladybug will have traveled 1, 2, 3 centimeters in that time, okay? So that right there should help you kind of analyze and figure out how long it's going to take the ladybug to make it 12 centimeters, and also take a look at the ant and try to figure that out as well. Now, the vertical and horizontal axes, labeling each grid line with a number, you will need to use the time and distance information shown in the tick mark diagram. So I'm giving you in here the 1 centimeter per line on the tick mark diagram, but you'll notice that you're going to have to supply what these are worth and what these are worth to kind of help you make that judgment. Okay, make that judgment of how much time is each one, or how long each one is going to be, and also by extension how much which line represents the ant, which one represents the ladybug. Now, mark and label the point on line U and the point on line V that represent the time and position of each ladybug after they have traveled 1 centimeter. All right, now that one's going to be a little bit trickier. Again, it depends on how you want to label this, how you want to connect this graph to these lines, okay? Marking and labeling a point on line U that represents the time after 1 centimeter. So you recall that yesterday when we played our click war game on Desmos, we were experimenting and looking for something called a unit rate. That's really what this question is asking you, okay? What is the unit rate, okay? In this case, the unit rate would be after 10, so how many seconds would it take for 1 centimeter? Okay, so in other words, figure out how much time it takes somebody to go something, and then divide it by 1 to figure out what this unit rate is, okay? After traveling 1 centimeter, how much time is it taking them for traveling 1 centimeter? Now here's a hint. In 2 seconds, this ladybug has traveled 3 centimeters, okay? In 2 seconds, this ant has traveled 5 centimeters. So what I'll tell you here is that if I want to know what this number is, seconds divided by centimeters, is going to be the case. So in other words, I'm going to be doing the time divided by the distance. Okay. Now that also, I will point out, does correlate to this graph. Time is on the y-axis, distance is on the x-axis. So the way we find out these rates is by kind of doing the same thing, the y divided by the x, which sounds like slope, which sounds like all the other work that we've been doing. So there is a connection between the previous units and what we're doing in this lesson. Now, how fast is each bug traveling? Well, each bug is traveling at a speed. How fast? Okay, now here's the other thing to think about is that if this extension question, which I think you should do, this extension question usually is referring to speed. Now, not to confuse you here, but if speed is being asked for, speed is distance divided by time. So it would be the opposite of what you're doing to answer question 4. In question 4, you do time divided by distance, but here, speed is distance divided by time. So in this case, if I were to use the Ladybug for an example, 3 centimeters in 2 seconds means 3 over 2 is the speed, or 1.5. Okay, so the hint here is that 1.5 centimeters per second is the for the Ladybug. Okay, not Ladybug, because 3 centimeters divided by 2 seconds equals that. Okay, so I'll let you answer that question for the ant the same way. Okay, now the only other question I can ask you about this particular diagram before we move on to the next section is, will there ever be a time when the ant is twice as far away from the start as the Ladybug? Explain or show your reasoning. This one here, you may want to make either a double number line or a table of values, okay? Make table or double number line. If you're not familiar with a double number line, don't worry, we'll see plenty of them throughout this unit, but there's nothing wrong with making a table. When I say make a table, I mean, like, you know, if the 1 second is going by, or 2 seconds to 5 centimeters, whatever, just basically track how far away each one is at the same time interval, and that will give you sort of our understanding here. So for example, if we do time, we do distance of the Ladybug. Let me do this if I can remember my shortcut keys. Nope. Okay. Super subscript. I don't know. I thought I had one. Ladybug would be here, and then the distance of the ant would be here. And then if I just basically make a table out of this here, just using my pencil for this, don't mind the non-straight lines here. But if I want to do that, then basically I would do this. Obviously at 0, the Ladybug is at the starting line, and the ant is at the starting line. But if I now go to 1 second, the Ladybug is, well, again, we already answered that question before, 1.5 centimeters away. How far is the ant? That's something you'll have calculated before. At 2 seconds, excuse me, then we know that it's at 3, and I'm just using the graph here to answer this question. We know the ant's at 5 at that point. So if we just kind of keep doing this, then we can get an answer. Eventually, one of these rows, the Ladybug will be half the distance of the ant, which also then means that the ant's twice the distance to the Ladybug. Okay, now, real quick, 1.3 here, the last few questions at the end here. Imagine the bug is moving twice as fast as the Ladybug. On each tick mark diagram, mark the position of this bug. So there's a third bug now, okay? You can call it whatever you want, a spider, whatever, right? Imagine the bug is moving twice as fast as the Ladybug, okay? So we know the Ladybug is moving at every 2 seconds, it's moving 3 centimeters. So every 2 seconds, this bug would be moving 6 centimeters, okay? Mark the position of this bug, plot the positions on the coordinate axis with lines U and V, and connect them with a line, and write an equation for each of these 3 lines. Now, for the equation part, this part here is going to be something that's a review from 7th grade, excuse me. So I'm just going to show one example of an equation, okay? Now, what you have seen so far, these are all examples of what you're going to learn is called proportional relationships, okay? So a proportional relationship is in the form of y equals kx. K is also known as the constant of proportionality, okay, which you may or may not remember from 7th grade. That basically, in this example, is going to be the seconds per centimeter that you had used in the previous example with the previous one. So for example, if the resulting seconds per centimeter, I believe for the ant it's 0.4, and if you made it this far, it's okay to get that. That means that for the ant, the equation would be y equals 0.4x, okay, with y being the seconds and x being distance. Okay, let me just slide this over just a little bit. Okay, so again, the equation here is just your constant of proportionality, which, where did I get the 0.4 from? That right here is from this seconds per centimeter that you got from the prior problem. So the ant's equation here would be y equals 0.4x. What did you get for the ladybug? Well, the ladybug, the equation here, the ladybug had traveled, I believe it was 3 centimeters in 2 seconds, so 2 over 3. So the equation here would be, if you like decimals, it would be y put 0.067x. Again, with the same seconds and distances for y and x. The ladybug's equation would be that. Okay. Now, for the third one, the third bug, which you can call whatever you want, okay, if it's traveling twice as fast as the ladybug, okay, then what is that distance going to be? Seconds per centimeter again, okay? If the twice the distance as the ladybug, that means 2 seconds, 6 centimeters, right? So because twice the distance of the ladybug, which is 3, right? So 6 centimeters. So that means 6 centimeters in 2 seconds. 2 seconds per 6 centimeters is 1/3. So the equation there would be y equals 0.33x if you like decimals, okay? There's nothing wrong with writing y equals 1/3 x as well, okay? Either of those would be fine. So there you go. I just answered question 3 for you, all 3 parts. When if there's any questions, you can just kind of go back and use this knowledge as well. Now, the last thing I'll tell you is that there is a cooldown that I do want you to do. Do pay attention on the cooldown to the labeling of where the x and y axes are to help you answer this question, okay? So anyway, that's the video lesson, and hopefully you made it through, and hopefully it's helpful. If you have further questions, if you're one of my students, please email me. If you're not one of my students, you may feel like posting a comment here, and I will try to assist you as well. Anyway, have a wonderful rest of your day. Take care.